and we're going to finish up chapter 3 and probably get a little bit into chapter 4, which only has 2 sections, though. Admittedly, the last section is of chapter 4, a little bit more involved. Arithmetically, deals with compounding, and but that will happen on Wednesday. And at the conclusion of chapter 4, we will have our second exam, and then we'll be on to talk about statistics and probability. Okay, so, but to start today, we're going to look at something that everyone has heard one time or another on the news, never really probably thought much about the mathematics of it, and what we call index numbers, and specifically consumer price index and what it is. All right, give me a second. I got to see what's going on upstairs. My dogs are going crazy. I'll be right back. All right, I apologize. All right. Hopefully it'll stay quiet. My neighbor's dogs are going crazy, and it's got one of my dogs worked up. All right, so let me get my whiteboard up. And looking at 3D. And we're going to talk about index numbers. Now, these are used really for comparison, comparing numbers at the end of the day. So we can compare different kinds of measurements from different times, different places. And so, hold on. And we can pick any, there's no like one you have to use this year as your reference number. That's your choice. And then you're comparing it to another number. So I'm just going to define the formula out, basically an index number will be the value divided by your reference value, whatever that is that you're comparing it to. And that would give us a number in decimal form. So if we then multiply by 100, we're going to get a percentage. And now, there is no particular rule for where to round an index number. Generally, for purposes of this book, we'll round them in tenths, so tenths place. So as an example of what we're talking about, let's say we have a 1985 price. Of gasoline. And let's say was, I guess would be more grammatical. $1.20 per gallon. All right. And we're going to use that as our reference value. So we're comparing to 1985. So this will be our reference value. And we're going to compare that to find a price index for gasoline today, which again, I'm just pulling a number here. So it's a little low if you've been to the gas pump recently, but not too far off. So $2.70 per gallon. So using this as our reference value, we're comparing it to price today. So we would look at $2.70 divided by that $1.20. Okay. And then just multiply by 100. Now, so this times or divided by this would actually give you 2.25. Move the decimal place twice to the right. That's basically we're getting the percentage. So we get 225.0. All right. So more to the point, what does that index number tell us? Comparing the price of gas in 85 to today's price. Today's price is a whopping 225% of the price in 1985. Okay. All right. Now, again, as far as the reference value that is picked, it's whatever you want to compare to. All right. So let's look at something. I think we've all heard this phrase before, but something we're going to call David, I'm not sure I understand your question. You typed in reference value was 100.
Yeah, and I didn't mean to put the slash. It was a question mark, but I wasn't looking at my keyboard, and I'm not sure where my keys are. But when you say the reference value, at that time, you picked 100, but it could be a different number, correct?
Okay, so that times 100, that is just a mathematical way to write. We're taking that index number and turning it to a percentage.
Okay.
Per 100.
Right. So but for other problems, that reference number would be different.
Well, yeah. So the reference value is whatever you're going to compare to. In this case, I want to compare today's price of gasoline to the price of gas in 1985. And so here's today's price, 270, and then you divide it by your reference, the one I'm comparing it to, 1985. So 2.70 divided by 1.20 comes out at 2.25. The times 100 is just that's just to turn it to a percentage.
Oh, okay.
And
so 100 is not your reference number. Your reference number
no, that is
are
just
the other.
this.
Okay.
Yeah, this number right here, that is just a mathematical way to say turn to a percentage.
Okay. All right. I got confused there when I wrote it down. That
Okay.
I understand what you're explaining.
And
now.
So then I can conclude that again, today's price is 225% of the price, in 1985. You can turn that around, incidentally, and let's do that real quick. If I consider this to be the reference, okay, and want to compare, okay, how much less was it in 1985, then you would do this, flip it. So again, this is just turning to a percentage. Now, this one I don't have a number. I got to actually figure it out. So 1.20 divided by 2.7. And we're basically going to get this. So so the price of gas in 1985 was 44.4% of what it is today, which, again, makes sense. If you just look at the numbers, this is, comparing it this way, and I'll say, okay, it's 225% more. And it is definitely more than double what it was in 85. But if I compare the other way, I would say, okay, this is definitely much less. So, but what you choose to be the reference value is again, just depends on how you're comparing. So, but at the end of the day, we're just getting a percentage. So, as far as mathematically speaking. Now, turn the page back to 2, and we're going to look at a very specific index number called Consumer Price Index. All right, so, and what is this used for? It is an index number we can use to compare prices. So here's the issue. There are two things that happen to price of goods. One is called, and we could flatline it, but generally either prices plus income go up, which we call inflation, or they go down, we call that deflation. And for the most part, we have inflation. Now, at times, now I was a little guy, so I didn't really understand. I just remember my parents talking about it a lot. There was rampant inflation in the 70s, particularly mid to late 70s. And then it kind of backed off. And right now we are dealing with some inflation. So the thing, what the CPI, the Consumer Price Index, does for us, it allows us, because if you just compare prices from different periods and you don't take inflation into account, you really don't get an accurate idea of the pricing comparison. So it enables us to compare prices and kind of taking inflation or deflation out of the mix, so to speak. All right, so this, and I'm going to go ahead and give a little definition, is based on an average. So how do economists find this consumer price index? So it's based on an average. of prices for a sample of, look at this number, 60,000 goods, services, and housing costs. So we're not going to really get into how this number is arrived at and the mechanics of it, but we will say it is computed and reported monthly. All right, so basically, tracking is done over 60,000 different goods, services, housing costs, and this index number that we're again calling consumer price index is calculated on a monthly basis. All right. Now, boy, how do I show this? So when you get in to do some of the homework, you're going to be looking at some tables and using numbers from tables. And just in terms of how we read the tables, let me figure out how I can do this quickly. So I'm going to write down a small table. This is just dealing with back to gasoline prices that we had looked at one computation. Again, this is really just looking at how to read a table. So it's got the years 1965, 1975, 1985, 1995, 2005, and 2015. So every 10 years. And so there's your year. And here we're going to put price. So what was the price per gallon for gasoline in each of these years? 31 cents, 75, 57 cents, 85, $1.20, which we had used that number previously. 95, $1.21, so didn't go up too much, but in 2005 it shot up to 2.31. 2015, 2.52. All right, this column, price index. All right. And so I'm going to write down 25.8, 47.5, 100, 108.8, 192.5, 210. Okay, now I've kind of run out a little bit of room here, so I'm going to, on the table itself, it actually has it right below this. In parentheses, it has 1985 equals 100. And that's really what I wanted. So when you see a table and you see this, what does this mean? I'm going to do one more column. I'm going to write price index again. Boom. And I'm going to write down some different numbers. 13.4, 24.7, 51.9, 52.4, 100. 109.1. All right. And here we're going to have 2005 equals 100. All right. So remember, and I'm going to flip right back to this. I want to go back to here. I was comparing right here gas in 1985 to today's price, which probably was, oh, shoot. $2015. And remember, we came up with 225. All right. Now it must have actually been a little bit beyond 2015. But you'll notice in this column right here where it says 1985 equals 100, the price index was what? 100. So what this means is, what's the reference here? What's the reference value? This is telling you, it's comparing, this table right here is comparing everything to the price in 1985. So in 65, the price was 25.8% of what it was in 1985. And it was 75 is 47.5 of what it was in 85. In 2015, it was 210% of what it was in 1985. But all this is telling you is what those indexes are based all on 1985. So this one, it's basing everything off of the price in, or the reference price is from the year 2005. So when you see this, that tells you everything, what everything is being based on. And right here, it would make sense. It would be, exactly at 100, because you divide a number by itself, you get 1. Read the decimal place twice, you get 100 or 100%. So you will be looking at tables where you're given a CPI table, and it's going to have in there, what everything is being based on. But again, this is giving me a percentage. So I'm looking at a average annual consumer price table, and everything is actually based, the CPI index number is based on an average of prices between 82 and 84. So like where it has 2005 and it has the CPI as 195.3, we know that the prices in 2005 were 195.3% of what they were back in 82 and 83. Okay. So, so the toughest thing right now is I can't, and you will see these tables and where you're pulling the numbers, but it's, when we look at a CPI table, you're going to have index numbers and years listed out just like this. This example table of gas prices that I have right here. So you can find the table that I am talking about in your e-text on page 170, table 3.4. And this is your average annual consumer price index. Okay. So, how to use the table. Let's do an example. All right. So let's suppose that you needed $30,000 to maintain a particular standard of living. So we're going to need $30,000 to maintain some particular standard of living. In 2010. Okay. So the question is going to be, how much would you need in 2016 to have the same standard of living? Okay. So you're making the assumption that prices have raised at the same rate as the consumer price index. But what you would do is you would go to this table, and again, it just has every year listed out and then what the CPI is for that particular year. And so we're comparing how much more would I need in 2016 to what I needed in 2010. So this would be my reference. And the way I'll notate it is I put capital CPI, and then in the subscript, we put the year that the CPI, what that index number is for that year. So this would be the 2016, and we're going to divide that then by what the index, consumer price index, is in the year 2010. And so you would go to the table and you would pull out 240.0, and this was 218.1. Okay. All right, so now I'm not writing this as a percentage. I'm just writing it would come out 1.100. All right. Double check that. And that's exactly what I get. Now, so it's not right now, I don't have it as a percentage, but it's basically 1.1. Or the prices in 2016 and whatnot will be 1.1 times what they were in 2010. All right, so how much more would I need then? All I need to do is go 1.1. I needed in 2010 $30,000. Multiply that by 1.1, and that's going to give me $33,000. Okay, so I could conclude to have exactly the same standard of living, buying exactly the same foods and services and so on and so forth as I was in 2010. In 2016, I would need $3,000 more. Right, any questions on that? Okay. All right. So let's talk a little bit about inflation. So rate of inflation. Refers to a relative, and we know that word is going to mean percentage. A relative change in CPI, or Consumer Price Index, from one year to the next. Okay. Now remember, I said late 70s. Inflation was actually pretty stout. Prices were increasing like crazy. All right, so how would I, remember we're looking at a relative change, that's a percentage. This is a calculation which we have done in other settings in context, but the calculation will be the same. So if I, again, looking at the consumer price index table where I've got my indexes for price indexes for each year, if I wanted to know what was the rate of inflation from 78 to 79. So and let's be grammatical, was inflation rate from 1978 to 1979. Right. Well, I would want to know the absolute change from again, I'm comparing to, this would be my comparison. And I'm looking to go to here. So the calculation would be take your number from 1979, subtract the CPI from 1978, and divide that by the CPI of 1978. So you would go to your table, pull those numbers off the table. You'd have 72.6 for 79. That would be your price index for 79. Minus 65.2. And divide that by 65.2. And you're going to get 0.113. So multiply it by 100. And you have 11.3%. So your inflation rate from 78 to 79 was 11.3%, which is pretty high. If you compared, do the same calculation using that same table and look at the inflation rate, just to get an idea of how bad it was in the late 70s, compared from 2015 to 2016, do the same calculations, pull the numbers off the table there. Inflation was about 1.3%. So much less. I would venture to guess right now it's a little higher, but it's not anywhere approaching what it was in the late 70s. Okay, so I had said that we could use the consumer price index to look at prices, comparing prices from, say a long time ago, and adjusting for inflation. All right, so this is a formula that you will use a good bit. I'm going to put up here. So adjusting prices for inflation. Oh, that's really bad. All right. Adjusting prices for inflation. Okay. So given the price in dollars for some year. So let's write this as for year X. So whatever year that you particularly pull out of there. And we'll notate this as the price for that particular year X. That's all this little bit in parentheses means. Right? The equivalent price in dollars for another year that you want to know what the price would be for that same thing, adjusting for inflation. So we'll call that year Y. Put in dollars for year Y. All right, is, all right. Price this year, so year Y. So we know we're given a price in some year, we'll call X. We want to know what that price would be in some other year, adjusting for inflation. So that price in year Y will equal whatever the price was in the year we know. Price of is not of in price in year X. So new year X times CPI of Y divided by consumer price index in the year X. Okay. And this right here, make sure you note that formula because you use it a good bit in homework problems from this section. All right, so let's look at an example there. All right. So, well, let's see if I can. I'm going to try something. Give me a second here. I don't know if I can do this or not. Make an attempt at something. All right. So now where? All right. Can you guys see that picture?
Yes.
All right.
Yes.
That is me at bat Sunday night. I don't know how many of you guys are familiar with the St. Mary's area. If you're not, no big deal. Just it's a little personal thing about me. I have been playing baseball forever, and that was my favorite game as a little guy. I play in we have, in fact, we're the only one in the state. Thank you. So that picture, the picture itself was actually taken by my father-in-law. Anyway, and we're the only adult league in the state. I've been at it for a long time. So I'm in the twilight of my career. This will be my last season playing baseball. I play with most of the guys I play with are in their 20s. So, and I'm a long way from being in my 20s. So I don't have a lot of speed left, but I can still hit. I went 1 for 3 in this game. This one was kind of normally we play at City Park, but we played all over. But we had never played in St. Mary's, and I was actually, as a little guy, from St. Mary's. We moved when I was 9. So the first baseball I ever saw was on this particular field. And so first, so circle back and get to play a game there was pretty cool. So it's just a little bit of personal stuff about me again. So I'm going to close this picture out, and let's get our whiteboard back up here. So what was the connection? So remember, adjusting for prices for inflation, and this is our formula to do that. I did run the league for a long time, and I did not get paid for that. It's a strictly voluntary thing. Managed a team for several years, again, very voluntary, and none of us players get paid to play in this league. In fact, we have to, but it is expensive because you've got to pay for insurance, you got to buy baseballs, you have to pay the umpires. Can't play a game without umpires. So it generally takes I don't know, neighborhood of about 6,000 to run the league for the year, and so we pay for that. The problem I want to look at is baseball salaries in Major League Baseball. So, and comparing some salaries of MLB players. I had high school talent and Legion talent, and that's about as far as my game went. I wasn't going to definitely be on the pro level. So wish I could. Just even if I could play a couple of years, I'd be set for life. All right, so we're going to compare using our formula here. The average salary. So let's be our example. Average salary in 1987, 3 years after I graduated high school. For a Major League Baseball player was, so this is the average salary, $412,000. Pretty good living. Be a pretty good living today. All right, so in 2016, the average was a little bit more, $4,380,000. Now there's your average for the year 2016. Okay. All right. So what we're wanting to do here is we're wanting to compare the two average salaries, but in 2016 dollars. So that is, we want to take what the average salary was in 1987 and compute what that would be adjusting for inflation in 2016. All right, so that is what our goal is here. So that is, how does this, because certainly this dramatic increase from 412,000 to $4,380,000. We want to compare that price increase and see if that actually was right with the rate of inflation, or was it beyond the rate of inflation. All right, so here we go. So we're going to convert the 87 salary in 1987, we will multiply that by, and this is where again you would pull off the table, go to the year, find what the consumer price index was for that year. 2016, we will divide that by the consumer price index for the year 1987. Okay. So what this is going to do is convert what that salary was in 1987, and using the CPI from each of the 2 years would give us, using adjusting for rate of inflation, what it should be in 2016. Well, when you do the computation, you would have then 412,000 times CPI in 2016 was 240. No. CPI in 1987 was 113.6. So rounding to the nearest dollar, well, actually rounding to the nearest $100,000, 870,000. Okay. So, question. Now that we made this calculation, have the salaries of baseball players far exceeded inflation? What's your gut feeling there? Now, because remember what this number is right here is taking the number, when you do this calculation, it takes what the salary was, the average salary was in 1987, adjusting for inflation, what the salary, if the salary just increased by the rate of inflation, then in 2016 it should be 870,000, but it's not. It's 4,380,000. Right, so quite, the average salary baseball players have increased way more than what the actual rate of inflation was. We can argue on, or not argue, but debate and talk about, I don't know what the answer is on this exactly, but other than I wish I was a Major League Baseball player, but quite very dramatically, the salaries have increased way beyond what the rate of inflation is, has been. So, like I always said, I don't begrudge anybody making money, so don't get me wrong. But good work if you can get it. But it is hard. It is very hard to be a Major League Baseball player. I do know that. I know enough about baseball to know, what it takes, and it's a skill set that very few people have. Is it worth that? That's where we can, I don't know. But I think it shows a dramatic change. But that's how I adjust for inflation. So I can take any price or a salary, but a number from a particular year, use that CPI table to figure out, just adjusting for inflation, what it should be in another year. Okay. And there are other index numbers. You're only going to really work with CPI. There's PPI, for producer price index. how much producers have to pay for goods they purchase to make other goods. There's what's called the Consumer Confidence Index, to measure consumers' attitudes to business engaged are likely to spend or be saving, so on and so forth. So, all right. With that, where are we at now, time-wise? Excuse me. That is basically 3D in a nutshell. There are, I believe, 15 homework problems. Give me a second. It's locked me out. I gotta log back in. All right. Yeah, I think I'm there. Yeah, okay. There are 15 problems. And then the problems requiring a table, they give you the table. So you don't have to go to the textbook to look it up. The first one is number 7 that requires a table. The table's right there. Number 8 uses the CPI table. And the problems are worked in the same fashion as examples I have done. And so every problem that requires a table, the table is actually listed right there. Number 12, you actually have to click on an icon to pull the table up. There is a print option if you have a printer, though you don't need to print. I think that's there's 14. You also have to click the icon. So there's 2 of them that you have to click an icon to get the CPI table. Number 15, you're given the CPI table, but you're also needing, because it deals with minimum wage, you have to click to bring up a table of federal minimum, what the federal minimum wage was for particular years. And really it's that particular problem is just looking at, kind of like we did with baseball salaries here, does the minimum wage, has it been adjusted for inflation? Is it over or under? And so you'll do the calculation there. Okay. And that will be it for chapter 3. There will be a chapter 3 review quiz that I'm going to assign in addition to the homework in 3D. All right. So in chapter 4, there are 2 sections. That's it. And then we'll be ready for the test. Definitely not getting to 4A, 4B, not getting to 4A, or get 4B today. I will finish that up on Wednesday, but I will talk about 4A today. And computationally, it's not, there's not a lot to it. But what chapter 4 is dealing with is managing money. Right? So something we all have to do. And 4A is really talking about mechanics of dealing with your finances in a positive, kind of responsible way. And I always said, this is common sense, but quite honestly, when I was young, I had to, and I've kind of always been this way. I tend to learn things the hard way. I got to feel the pain as I understand. Don't do that. So when we talk about controlling our money and whatnot, well, don't take a credit card that has a $20,000 limit and max it out. Not a good financial plan. And the reason being is you got to pay exorbitant interest on it. And so if all you're making is minimum payments, you may spend 30 years just trying to pay the card off, and you've paid the credit card company 3 times over what you borrowed. But that is what 4A is all about. It's just about, it's entitled Taking Control of Your Finances. And so I was just looking at, and it starts on, it's a good read. Starts on, let me turn the page here, 4A, in the textbook, page 192. And so what I want you to do is read through 4A. So I've actually asked this one, I'm asking you to get into the e-text and just read through it, starting on page 192. All right, so it goes through, first off, how do you control your finances? Well, know what's in your bank account. That is checking, savings, know what you got. Never write a check if you can't cover it. Never withdraw money if you don't have it. And then know what your spending habits are. Now, so that means knowing what your, all your bills that you have to pay regularly, plus what you normally buy for food, gas, and then what I call just kind of the peripheral sundries, and know how much you spend. And then I suggest don't buy on impulse. Always be well planned out on what you purchase. Now, I always like to do this on impulse buying. If I go on a vacation, and vacation is meant to be relaxing, and sometimes people enjoy shopping. I put away so much money for impulse buying on vacation. Just something I see and I go grab it, but I kind of plan it out. But what that is all leading to is budgeting and making a budget, and then staying within that budget. And then staying, always staying in there. Now, in determining a budget, you flip the page on 194. What you got to do there is, we're making a budget usually by the month. Figure up how much money you are bringing in per month. And then what do you have as expenses per month? And then you compare to how much you bring in to how much you spend. Hopefully that comes out not negative, because if it's negative, then you've got to readjust for sure. Then you figure up your net monthly cash flow by subtracting your expenses from your total income, right? And then make adjustments as needed. And so looking at the homework from here, on 4A, I think there were like 21 problems, but nothing super onerous. It takes a long time to do calculations. When we move to 4B, and start talking about saving and interest rates and compounding, and it gets a little bit more involved. But again, we're not doing that today. So I'm just kind of going through the problems here. Since there's nothing here that should be too terribly difficult in this section. So what I'm going to do is I'm assigning 3D. What we went over. Today is the 12th. So I put the 14th as the due date. Of course, you can work past that. I'm assigning the quiz for chapter 3. I'm putting the 14th as the due date on it. Okay. And then I'm also assigning 4A. Now, on 4A, I'm putting the 14th on it as well. Yes. Never been a big fan of 3E, section 3E. I just don't think it was well constructed. And as far as the book, it's very ambiguous and subjective. So, and plus I want to save some time for statistics. So and there were a few quiz problems from 3E. I removed those. I'm going to double check. Let me make sure I did. Those questions. Thought I got them out. I did. All right. I'd done that earlier. So there will be no 3E. Okay. But on 4A, which I put the due date for 7/14, there are 21 problems, and I said there's nothing too onerous. I want you to read through 4A in the text and then work those homework problems. But I want to go and pare it down a little bit and remove a few of the problems before I assign it. So it won't be 21. It's going to be a number smaller than that. I don't know, probably, I'm just ballparking it here. Probably we'll remove 2 or 3, maybe 4 problems. But it should actually go fairly quick. So certainly we'll take questions on homework on Wednesday. And then the main emphasis, I want to get 4B. And 4B will take us a little more time and compounding and looking how interest compounds and the different ways we can compound it. For me, to me, it's an important section, just life skill wise, things to know about taking loans out and also savings and how to understand compounding. So after we leave here, I'm going to go in and trim 4A down. I will sign it here before the 1 o'clock session. So are there any questions homework wise or whatnot? So I'm going to put a little homework signed. 3D, the Chapter 3 quiz, and 4A. And that is for you guys to work for Wednesday. So I'm going to go ahead and stop.